far away from the Sun. In a place where light is weak and temperatures are unimaginably low, there is a world locked in ice. The temperature is so low that everything on the surface is locked solid. Nothing should be moving, and yet, water is erupting into space. Not just ice, not just water. Massive jets carrying chemically active material. And these jets aren't coming from the surface. They're coming from deep below, which means something is happening beneath that frozen crust. Something moving, something producing energy. A system that is still active. Enceladus, a moon of Saturn, looks like nothing more than a simple ball of ice from the outside, but its interior may be one of the most intriguing environments in the entire solar system. So the question is, beneath this frozen surface, could there be a living ocean? And more importantly, could something be alive down there? Enceladus is Saturn's sixth largest moon. A small world measuring only about 500 kilometers across. On a planetary scale, it's almost insignificant. But as science has shown time and time again, size isn't everything. Because this tiny moon is home to one of the most important discoveries in modern planetary science. At first glance, its surface is deeply misleading. Enceladus is one of the most reflective bodies in the solar system. Covered almost entirely in clean, bright ice that reflects most of the sunlight it receives. For a long time, that brightness gave scientists the wrong impression. It was thought to be geologically dead, frozen, inactive, and unchanging. If you were searching for life in the solar system, this is not where you would start. It's not warm, it's not bright, and it doesn't seem habitable. But that assumption began to break down. In the 1980s, when the first images from Voyager 1 and Voyager 2 arrived. Those images revealed something unexpected, large regions of the surface with almost no impact craters. And that detail matters. Because a lack of craters usually means the surface is relatively young and constantly being renewed. What this means is, Enceladus wasn't a dead world after all. It might be geologically active. The real turning point came in 2004, when the Cassini-Huygens mission entered the Saturn system. What Cassini observed went far beyond expectations. Enceladus wasn't just active, it was ejecting massive jets of water into space. From its south pole, plumes were blasting hundreds of kilograms of water vapor and ice particles every second. That discovery alone was revolutionary, because it provided direct evidence of liquid water beneath the surface. And at that point, scientists began asking a very different question. Is this just a frozen moon, or an ocean world hidden beneath ice? The massive jets of water erupting from Enceladus immediately pointed scientists toward a single conclusion. That water had to be coming from somewhere, and that source had to lie beneath the surface. But this raised a serious problem. Enceladus is both small and extremely distant from the Sun. So where was the energy coming from to keep that water in a liquid state? At first, scientists proposed a simpler explanation. They suggested the water might originate from a small, temporary reservoir near the South Pole, a localized pocket beneath the surface that periodically froze and melted. This idea made sense. It required less energy and seemed more consistent with Enceladus' small size. But the data didn't support it. When researchers analyzed the high-precision observations collected by the Cassini-Huygens mission over several years, they noticed something unexpected. Enceladus exhibited a larger-than-expected wobble in its rotation. And that detail is critical, because such a motion is only possible if there is a decoupled layer between the surface and the core. What this means is, there must be a liquid layer separating the outer shell from the interior. Today, the strongest model suggests that Enceladus is home to a global ocean, one that extends beneath nearly the entire surface of the Moon. This isn't just a small, localized body of water. It's a planetary scale system. That realization marks a major turning point. Enceladus is no longer seen as just a small, frozen moon. It is now classified as an ocean world. But this leads to an important distinction. The presence of water alone is not enough. The real question is whether this ocean is active, or simply a passive body that has not yet frozen solid. Because if the system isn't dynamic, then the range of possible chemical processes would be extremely limited. And that brings us to the next critical piece of the puzzle: energy. When you look at the surface of Enceladus, one thing becomes immediately clear: it isn't uniform. The South Pole, in particular, stands out as a completely different environment. This region is relatively smooth and geologically young, but its most striking features are the long, deep fractures that stretch across the surface. Scientists call these features the tiger stripes. These fractures aren't just surface formations, they are active gateways into the moon's interior. The massive jets of water, observed escaping into space, originate directly from these cracks. At Enceladus distance, the sun provides almost no usable energy. So the heat required to sustain a subsurface ocean must come from another source. Measurements from the Cassini-Huygens mission revealed that this region is noticeably warmer than its surroundings. The temperature difference may seem small, but in such an extremely cold environment, even a few degrees indicate a significant internal energy source. This tells us that the South Pole is not only structurally different, but also powered from within. So what exactly is generating this energy? As Enceladus orbits Saturn, it is constantly being flexed by the planet's gravity. This repeated deformation creates internal stress, which is gradually converted into heat. That heat doesn't spread evenly, it concentrates in specific regions. The South Pole is one of the primary locations where this energy reaches the surface. The fractures in this region allow heat and subsurface material to escape, which is why a continuous outflow of water and ice is observed. And this isn't a short-lived event, it's an ongoing, long-term process. This leads to an important conclusion. Enceladus is still internally active. The mechanism that generates this heat appears sufficient, but on its own, it's not the whole story. That energy also needs to be transferred into the ocean below. This is where the system becomes more complex. Enceladus' core is likely not solid and compact, but porous. This allows ocean water to seep down into the interior. As the water moves deeper, it heats up and rises again, creating a continuous cycle of energy and material transfer within the system. This process is remarkably similar to hydrothermal systems on Earth. And that similarity matters. On Earth, hydrothermal vents on the ocean floor support entire ecosystems that function without sunlight. In these environments, energy comes directly from chemical processes. On Enceladus, this internal activity keeps the subsurface ocean from freezing and drives constant motion within it. This is not a static system, it is dynamic, with energy circulating from the interior all the way to the surface. The material ejected into space doesn't just disappear, either. Some of it spreads out and becomes part of Saturn's E-ring. What this means is, this small moon actively influences its entire planetary system. At this point, it's no longer possible to think of Enceladus as just another icy moon. Because this is not simply a frozen surface. Beneath it lies a system in motion. A system powered by energy flowing from the inside out. And that brings us to a critical question. How long has this process been going on? Because the longevity of a system like this is one of the most important factors in understanding what it might be capable of. The key question about Enceladus activity is how long it has been going on. Because short-lived activity would point to a temporary geological event, while a long-lasting system suggests something far more significant. Surface observations provide an important clue. In several regions, the number of impact craters is remarkably low. That matters because a low crater density indicates the surface is being continuously renewed over time, evidence that active processes have been at work for a long period. Data from the Cassini-Huygens mission supports this picture. The distribution and intensity of heat escaping from the surface are not random, they point to a stable and sustained internal system. This leads to an important conclusion. the activity on Enceladus is not temporary. It is most likely a long-term process operating on geological timescales. In simpler terms, the system shows three key characteristics: continuous internal energy production, active surface processes, a stable thermal balance. Together, these conditions indicate that the system has not just been active recently, it has been operating for a very long time. And that naturally leads to the next question. In an environment that has remained active for so long, could more complex processes have had time to develop? At this point, the main question about Enceladus is no longer water or energy, since both are strongly supported by observations. The focus has shifted to whether the environment could remain stable and complex enough for life-related processes to begin. What matters is the long-term coexistence of these conditions. Data from the Cassini-Huygens mission shows that material from beneath the surface contains water, simple gases, and organic compounds, pointing to a more complex system than a simple subsurface reservoir. An internal heat source keeps the chemistry active and continuously renewed, driving an ongoing cycle instead of isolated reactions. This resembles Earth's deep-sea hydrothermal systems, where chemical energy can sustain long-term biological potential without sunlight. A similar mechanism may exist on Enceladus, supporting internal energy flow despite its distance from the Sun. Together, the observations form a chain: liquid water, sustained energy, and organic compounds in the same environment. This does not confirm life, but it does show that the required conditions could exist. Enceladus is therefore no longer seen as just a moon, but as an active system with continuous internal processes and material being ejected into space. There is still no final answer, but it is clearly not an ordinary frozen world. Today the question is no longer only about conditions, but about whether anything has already started there. If you enjoy deep space stories, scientific discoveries, and exploring the unknown corners of the universe, don't forget to like the video and subscribe to the channel. That way we can continue sharing new discoveries together. See you in the next video.